Have you ever stopped to think about what actually happens when you hit send on a calendar invite? I mean, it feels totally instant, right? But behind that one simple click, there's this incredible high-speed journey happening in the cloud. So let's pull back the curtain and follow the data to see what's really going on.
So really, think about it for a second. You just scheduled that meeting, you clicked the button. Where did that little packet of information actually go? It definitely didn't just magically appear on your coworker's calendar. No, it went on a trip.
And the very first stop on its journey is this place we can think of as a super high-tech digital post office. The technical name is the Calendar Invite Server, and its entire job is to handle these little digital letters with amazing speed and reliability.
Now, before we follow our invite all the way through, we kind of need to meet the crew that makes this whole operation work. You see, inside our digital post office, there's a whole team of specialized workers. These are cloud services, and each one has a very specific and very important job to do. Okay, so here's the team. First up, you've got AWS S3. Think of that as the mailroom. It's where every single invite is safely stored the moment it arrives. Then there's AWS SQS, which is like the sorting conveyor belt, making sure all the jobs get lined up in an orderly queue. Our star employee is a specialist robot called Lambda. Its job is to do one specific task, but to do it perfectly, thousands of times a second. All the important info gets stored in Amazon DynamoDB, which is our master filing cabinet. And finally, you have AWS Code Build. They're the automated upgrade crew that can basically rebuild the post office with new features without ever shutting it down.
All right, now that we've met the team, let's do it. Let's follow one single calendar invite on its crazy fast journey through this whole system. We're going to see exactly how it goes from your sent folder to a saved event on a server. The whole thing really just boils down to 3 simple steps. First, there's the arrival, when the invite shows up. Second is the alert, where the system gets a heads up that there's a new job to do. And third, the action. That's where the real work happens. So let's break them down one by one.
Okay, step 1, the arrival. This is all about security and making sure nothing gets lost. The absolute instant your email hits the server, it's captured and immediately tucked away in AWS S3, our digital mailroom. It's like a mail clerk instantly putting your letter in a secure vault before it even gets sorted. That way, it's impossible to lose.
So once that invite is safely stored, the mailroom sends out an alert. A little notification gets put on that digital conveyor belt, SQS, which basically tells the rest of the system, hey, we've got a new piece of mail right here at this location. Get ready to do your thing. And finally, we get to the action. Our specialist robot Lambda sees that new message pop up on the conveyor belt. It zips over to the mailroom, grabs the invite, reads all the important details, the who, what, when, where, and then files everything perfectly into our master filing cabinet, DynamoDB. And just like that, poof, the invite is processed.
But what's almost as impressive as how an invite gets processed is how the system itself gets improved. I mean, this digital post office can get a total renovation while it's still running at full speed. So how in the world do developers keep everything running so smoothly and add new features all the time?
Well, it's constantly evolving, and the magic behind that is a process called CI/CD. That stands for continuous integration and continuous deployment. And really, that's just a fancy way of saying there's an automated process for developers to release updates, add new features, and squash bugs, all without you ever noticing a disruption. And this whole process is shockingly simple for the developers. Now, I know the commands you see on the screen look a little technical, but the reality is a developer can kick off a major update with just 2 simple instructions. They tag a new version and push it. That's it. From that point on, our automated upgrade crew, AWS Code Build, just takes over and handles the entire deployment from start to finish. It's all automatic.
But just because it's automated doesn't mean it's the Wild West. There is one golden rule, and it is absolutely critical. All changes have to go through what's called a pull request. This just means that every single change, doesn't matter how tiny, has to be reviewed and approved by other developers on the team. It's this huge safety net that keeps the quality high and prevents mistakes from getting out.
So, after seeing all these moving parts, you might be asking yourself, okay, why? Why go through all this trouble? Why build a system this way? And the answer is because this isn't just a system for handling calendar invites. It's actually a blueprint for how the modern internet is built.
The benefits of designing things this way are just immense. The system is efficient enough to scale and handle millions of invites without ever slowing down. The automated updates mean you get new features fast, without any downtime. And most importantly, security is baked into every single step. Your data is encrypted, access is controlled, and everything is kept private. So when you really get down to it, what we've just looked at is way, way bigger than calendar invites. This is a powerful, efficient blueprint for how you build pretty much any reliable, secure, and scalable application in the cloud today.
Kind of makes you think, doesn't it? The next time you send an invite or post a photo or even just stream a song, take a second to consider the incredible and visible digital journeys that are happening just beneath the surface. What other complex worlds are buzzing with activity just behind your simplest clicks?